In the last video, I showed you a simple class diagram which created two classes, animal and dog, where dog inherited from animal. Let's continue with this example by adding other methods that are really specific to dog. Let me bring up that dog's class diagram again. And we can see that the methods on dog are bark, run, walk and wag tail. Let's add these starting with the bark method. I'm going to make this method private because I'm going to call it from the move method. This is a reminder that not all methods need to be exposed, that is marked as public, especially if you only intend them to be called internally from the current class. I'll print the fact that the dog barked. Note that I am using print, not println. I'll copy and paste that method, changing the name of the method to run, and instead of woof, I'll change that text to dog running. I'll paste another copy of the method, changing the name to walk, and the text to say dog walking. And finally, I'll paste another copy, changing the name from bark to wag tail, and the text that's printed to tail wagging. Okay, so those are our dog behaviours. Let's use some of these methods from the dog's move method. I'll comment out the println statement first, then add some dog movements by calling some of our dog methods based on whether the dog moves fast or slow. I'll check if the dog's speed is slow. If it is, I'll start by calling the walk method, then the wag tail method. Otherwise I'll use else, which will be for a fast dog. Start by calling run, followed by calling bark. Because I used print earlier, I now need an empty println here to move to the next line. Now if I run that, the output shows the dogs moving. First, the Yorkie moves fast and then it prints dog running woof. Then I have the Labrador Retriever moving slowly and that's printing dog walking, tail wagging. Nothing in the do animal stuff method had to change for this new functionality to be called. I hope you're starting to get a little glimpse at how powerful a feature this is. Lastly, I can call the bark method in the overridden method make noise, which right now has no code in it. Here, I'm not calling animals make noise method and I don't want to. I want the dog to have some behaviour that the animal doesn't have. I'll call the bark method and use println to print an empty line. Let's run that. And now you can see that I get woof for both types of dogs when I call the make noise method in the main class. I've overridden the make noise method with code unique to the dog, which in this case makes a call to the bark method. And that's how you do it. You can separate the functionality that's just for a dog and only include it in the dog class. Let me try to change my make noise method again. This time, if the type of the dog is a wolf, let's have the dog howl and bark. I will test for the type of dog to be equal to a literal string, wolf. If it is, I'll make it howl. Again, I am using print and not println. Now in this case, where I'm referencing type, I get a compiler error. This is because type has private access in animal, but type is one of the fields inherited by dog. Yes, that's true, but because type is private on animal, no other classes, not even subclasses, can access or use this field in its own methods. I've said there's a modifier that allows access for subclasses, and that's the protected modifier. Let's go to the animal class and change the modifier from private to protected for the type field. What this modifier says is, let any class that is a subclass can access this field. This is conditional encapsulation. We're allowing some limited access to our internal fields, and that's to subclasses. Protected access also means that any classes in the same package will also have access, and changing that modifier means our code compiles successfully. Let's look at that code in dog again. Notice here that I just simply referenced type here. I didn't add any other qualifier, not this or super, and I didn't have to call type from a different instance of dog. This is another advantage of inheritance for fields and methods that aren't private. They can be accessed directly as if they really were declared on the subclass itself. Java first looks on the subclass for a method or a field with that name, then it'll go up the inheritance tree looking for a match. Let's quickly test this by creating a wolf in the main method of the main class. Dog wolf equals new dog and in parentheses wolf and 40. Call do animal stuff passing our wolf object and the literal string slow. And now running this code, you can see all the information about the wolf, and I also see the output that the wolf is howling as well as barking. That was the dog class. Let's add another subclass so you can get used to this inheritance concept and the idea of extending another class. Let's add the fish class to our hierarchy. What are some unique characteristics of a fish? Well, let's go with a couple like gills and fins. And instead of a generic move method, I might have more specific methods like move muscles and move back fins. Let's look at my class diagram that includes this new fish class. As you can see, it's quite a bit different from dog, but it's still an animal. This diagram shows the new class named fish that extends animal. It has two fields and two methods specific to its own type. Let's build that fish class. I'll open the project panel and highlight the SRC folder and select New Java class and give it the name Fish. Then I want to add extends animal as part of the class declaration. Then we'll add the two fields we showed, gills and fins, and then I'll add the constructor using IntelliJ's code generator . And like I did with dog, let's remove size, and this time I'll just change size to be hard-coded to small for simplicity. This constructor is a lot like dog's. I'm calling the super constructor, that is the constructor on animal, and I pass the type, the size, and this time I'll make all fish small. And finally I pass the weight. Then I add the assignments for fish's more specialised fields, gills and fins. So this class is very similar to the dog class, but in this case I've created a new fish class that inherits from the animal class, and I've defined some unique characteristics for the fish, namely gills and fins. Let's next add fish's custom behaviour and add the method move muscles first, and I'll just print out a statement for that. And I'll make this method private because I only want the move method to call it. I won't expose this behaviour, in other words, for any outside code to call it directly. And I'll just print a message, again print, not println. And rather than type in the second method, let me copy and paste the move muscles method and just change the name to move back fin and change the text to say back fin moving. And now I'll override the move method from animal so that the fish moves or swims. With my cursor right before the closing brace of the fish class, I'll start typing public void, and you'll see IntelliJ pops up a list of methods, and from that I'll select move. And now I have the overridden move method generated for me. Like I did with the dog class, let's extend this behaviour for a fish. I'll have my fish move its muscles regardless of the speed, but use its back fin if it wants to go fast. I'll call move muscles first. Next I'll check if speed is equal to fast. If it is, I'll call move back fin and add an empty println. That would be one way to model the fish moving or swimming. It moves its muscles and it moves the back fin, which the net result of that is it actually propels itself or moves. Let's add a code generated to string method for fish like I did for dog that prints both fish's fields as well as animals. Selecting code, generate, and then pick to string method. And that's it. I built the fish class. So let's create an instance of fish and call our doAnimalStuff method. And I can call that method with fish without changing that method at all because fish is another type of animal. Fish, Goldie, equals new fish, and in parentheses, the four arguments will be goldfish, 0.25, 2, and 3. Add a call to doAnimalStuff, passing our Goldie object and the literal string, fast. And running that, we can see the output from this additional code. Goldfish makes some kind of noise, goldfish moves fast, and there I have muscles moving, back fin moving. Again, I used animals' fields and behaviours, the ones I wanted to use, and then added some more specific elements, or fields, to the fish class. I passed fish to a method that never even had to know a fish class existed. I'm going to be coming back to this particular feature a lot, because it has a special name, polymorphism. Polymorphism simply means many forms. In this video, I showed that animal can take multiple forms, the base class animal, or a dog, or a fish. And as you've seen, some advantages of polymorphism are it makes code simpler. We can write code once using the base class or superclass, as I did with my doAnimalStuff method. I wrote that code without ever having to know about subclass types. I didn't have to write code to check the type of the object and then decide what method to call. Java did all that at runtime. It encourages code extensibility. It's very easy to subclass and override or extend the method that'll be called as I demonstrated. I have a whole video on polymorphism in the next section, where I cover this powerful object-oriented concept as well as others. Okay, so I've covered a lot of ground in the last 3 videos, introducing you to some key concepts of inheritance. What you may not have realised is that I've been using inheritance all along, even when you didn't think I was. That's because in Java, all classes, and that includes any we create, implicitly inherit from a single built-in Java class. Let's talk about that in the next video.